Hi, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome Brett Rampal. He is the Director of Nuclear and Power Strategy at Veriten, a Houston-based consulting firm. Brett, welcome to the Power Hungry Podcast.
Thanks so much, Robert. A pleasure to be here.
Now, we're newly acquainted. We met each other in person just a few months ago, in fact, in Houston at a Veriten event. We've known of each other, I think, for a while, but as I warned you before we started recording, guests on this podcast introduce themselves. So imagine you have about 60 seconds. You've arrived somewhere and people don't know you. Please introduce yourself.
Sure, absolutely. So as you said before, I currently serve as the Director of Nuclear and Power Strategies for Veriten. Prior to that, I spent, about 10, 15 years in the established nuclear industry. I worked for Westinghouse and General Electric Hitachi, as well as previously working at NuScale Power as a fuel engineer, supporting their first-of-a-kind licensing engagement. Last 5 years prior to working at Veriten, where I just started last year, I worked at a climate and an energy-focused environmental NGO called the Clean Air Task Force, and I helped lead their nuclear focus area. And now, in addition to working for Veriten, I consult for deep borehole nuclear waste disposal company called Deep Isolation. I also serve as a technical analyst for Segra Capital Management, and do some consulting for the American Nuclear Society. So I'm a nuclear guy through and through, but trying to get out of my old sort of stomping grounds. And that's how I met my wonderful friends in Houston.
Got it. Well, there's plenty to talk about, and you have a long resume. Let's talk about what the latest development here, which just has happened in the last few days, which is the NRC giving design approval to NuScale's reactor, which I think is a remarkable point in the history of nuclear in the U.S. I'm not going to overstate this, but this is a landmark decision, the first SMR. But here's the part that I did a short video on this because to me, yes, it's great. And it's super that we're getting some traction on SMRs, but it took 6 years for the NRC to approve this, even though the design of NuScale's reactor is almost identical to what the existing fleet. And they had to submit 2 million pages of documents, and it cost them $500 million in payments to the NRC. I mean, this is, it boggles the mind how long this has taken and how much it has cost. So can you, am I off in thinking that this is great, but how do you read it?
Well, it's certainly, a milestone, and, the design certification application that led to this design approval, this rule that was just issued. That's what I worked on when I was at NuScale. And I participated in that submittal in 2017. Now, yes, this took a long time, but also there were a lot of other factors at play here. Of course, as they said, this is the first design certification for a small modular reactor. This design certification pathway is a great sort of opportunity for reducing regulatory burden, but we've had a lot of certified designs, or several certified designs in this country, and that hasn't necessarily led into deployment. So many knew that when you're going into a certification, it's a similar analogous, it's an opportunity to reduce your eventual licensing burden, but it can, or it does have years on the road before you get there and everything. So yeah, this is definitely something we want to see happening more quickly, but also we got to remember that the design that was certified for NuScale is actually not the design they're going to deploy. They're actually going to deploy a larger, uprated version of this technology. And so to me, the more impactful or really cool news for NuScale actually this month, not this rule that came out, it would be when NuScale submitted earlier this month to the NRC their standard design application for that larger uprated reactor, the 77 megawatt one. And that reactor is going to form the basis for the carbon-free power project, which their first customers, UAMPS, want to deploy. So what that standard design application is just building on this DCA, that this certified design that they just got. So they took the 50, they did the legwork there, and now they're building upon it. Well,
Okay, so I'm sorry, I need to interrupt.
Yeah, sure, please.
DCA, forgive me. What does that mean?
Sorry, I apologize. That's design certification application.
Okay.
So that's what they did 6 years ago that kind of led to where we were earlier this month with this rule. Now, the review of that application did not take 6 years. It took, I think it's something like 44 or 48 months and everything, which is, of course, still a long time. I'm not defending the NRC. That's a long time. But the NRC and NuScale were also aware at that time that this certification was going to be something they were going to build upon. So the NRC was not being pushed by a customer or in a rush to issue this rule.
Okay. So and also just to be clear then, so the design certification application, that was for the 50 megawatt electric output reactor. But what you're saying is that NuScale is actually they're not going to deploy the 50 megawatt version. They're going to go with a larger version that's 77 megawatts.
Correct. And this new regulatory engagement that they began this month with the NRC, this SDA, the standard design application, allows them to build on an already approved design, essentially their 50 megawatt one, uprate it, reduce their regulatory burden in getting this new design recertified. It's essentially the same design, but just higher, power rating and everything. And also allows them a little bit more flexibility in terms of the site for these reactors, because originally their their certification application assumed a 12 reactor pool and only that size. Well, the new SDA, I believe, assumes a 4, 6, or a 12 reactor pool size, larger reactor outputs. So it offers a different sort of product for this first project, this carbon-free power project, to come online in 2029. But again, it's a stepwise, iterative regulatory engagement. But really and honestly, that is all driven by the languished regulatory, right? If we had had more of this going on for the last several decades, then NuScale wouldn't have the burden, and it wouldn't have taken as long for them to engage with the NRC. But this rule is great for NuScale. It's great for other folks that want to build upon this rule as well, perhaps use portions of it, use methodologies in their applications. And so that's the way we'll hopefully see this all kind of speed up in the next couple of years.
And fair enough. But the things that trouble me here are that this took so long, right? One, that the NRC would take 6 years all in, right? And I take your point about, well, it's only maybe 4. Okay. But still, and I did a short video on this, and I said it was 500 million, and Matt Wald, who's now working with Breakthrough Institute, said, well, actually it was $1 billion, that in fact it was 500 million that NuScale had to pay to the NRC to get them to do all their work. And there was another 500 million that NuScale had to spend internally. So that in fact, it was the total tab for them just to get their design approved was $1 billion. And
that includes, over $200 million in federal support funding that was included in that process to support.
And then 2 million pages. I mean, what can you possibly, I mean, that number, more than even the others, to me, stands out in thinking, well, Bjorn Lomborg had a point the other day. He was talking about the Millennium Development Goals, I think, that the UN had, and there were 169 of them, or something, 170 of them. And he said, well, if you have 170 of them, that's useless. You can have 5, you might have 10, but 170, there's no way you can pay attention to all of those, right? 2 million pages? You worked at NuScale. What in the name of Jesus, Mary, and Joseph is in 2 million pages of documents? And how could any regulator ever get around 2 million pages of documents? What is in there?
Well, I mean, it's basically what they put in there in this DCA, in this certification application, these millions of pages. I don't think it's 2 million pages. I think it was more like 12,000 pages. It might have been 2 million man hours.
No. I read 2 million pages. I'm certain of this.
No, that's fine. Well, to my original recollection, the original DCA, things might have spiraled and gone more, but the original DCA was a submittal of around 12,000 pages, or the original, 6 years ago.
Yeah.
Probably tons more paper interaction between there. That's only the submittal, so that does not include all the thousands of pages that myself and other colleagues produced internally at NuScale, and everything. So yeah, what they looked at was 12,000 pages originally, and even in that, and the work that NuScale did was great. The engineers that I worked with, all stellar, very, very talented nuclear engineers embracing, the principles of nuclear culture. The NRC found issues in that application, and there were actually open items in this rule that a future license applicant would have to resolve. But I believe, and thankfully, I'm reducing that burden for a license applicant. I believe NuScale is pursuing resolution of those issues in this larger the uprated version for this new larger reactor that they're doing right now. But yeah, I mean, it's the entire safety case for a new reactor technology. And I agree. I know your point. You're about to say it's not necessarily new, right? Because it's a light water reactor technology. We have light water reactors around the world operating everywhere and all that and everything. I totally agree with that. But, when you shrink this thing down and you want to do an integral module and you want to put everything that we used to have a lot more space above these reactors for, you want to have it all in a line in a smaller sort of configuration, that does introduce new operational intricacies, new regulatory intricacies. How does this all? So that's a lot of what was in there. Now, again,
let me stop you. I just found, here's the Washington Post. They reported 5 days ago, the first small modular reactor design application package included over 2 million pages of supporting materials, according to Hughes was the press person at NuScale. This was the source of it. And yes, the 12,000 page application, but 2 million pages. I mean, I was thinking about this before I did the video. I was thinking, okay, what's the fattest book I have? And then how tall would that be? And then, but it just seems absurd on a certain level though, Brett, that well, 12,000 pages is a lot too, right? I mean, this, here's my latest book. This is 300 pages, right? 12,000. I mean, how many, but the point there that just to revisit this is a light water design. This is just a smaller version. And I take your point that yes, there are technical issues that have to be resolved because of the way the plant is configured, but still the basic chemistry of this plant is no different than the fleet of 99 reactors or however many reactors we have in existence today. So I guess the big question, it seems to me, that is really the hinge around which the U.S. nuclear future is going to unfold is, can the NRC be a reliable regulator to make this happen on anything like a realistic time scale? I think that's the key question. Is that, am I off?
You're right. You hit the key question. It's going to be a challenge. But I used to support those existing reactors that you were just talking about, the light water reactor fleet, the 92, I think it's 92, it might be 93. I'm sorry, with Palisades chain, 92 commercial reactors currently generating 19% of the US electricity around this country and everything. Right. And just to reload one of those things, take out the fuel, put in the new fuel, do the outage, all that stuff, is hundreds of thousands of pages of supporting documentation to the NRC every 18 months, done on a basis where I would walk into the office for my plant and be like, I know what the answers to these analyses are going to be. We would guess and gamble to the decimal point on who could get it right, who, three significant figures, who's going to get it down to the, because that's how, in a lot of ways, repetitive these reload things got. But we still had to do the regulatory engagement because that was the way the NRC, and that's the way the 5059 process for restarting these, the 10 CFR 5059 process for restarting these reactors all works. So yes, the regulatory burden here is large, and the NRC is, facing a serious challenge. I believe I saw some of my colleagues from the Nuclear Innovation Alliance and Breakthrough Institute and some other organizations talking about how, and I've also looked into these numbers myself, that I believe the end of this year, the beginning of next year, or into the following year, the NRC is going to be looking at 10 plus individual regulatory engagements like NuScale's design certification that we're and standard design application that we're just discussing right now. And these things are, the licensing applications and regulatory applications for the fuel manufacturing facilities that TriSoX, the X Energy, and TerraPower endeavors are building. These are the licensing and certification applications for those projects as well. We should see an Oklo reapplication this year as well for their, micro reactor project at the Idaho National Laboratory. So yes, the NRC is looking down, pardon, this analogy, looking down the barrel of a large, pipeline of regulatory engagements. And in a lot of ways, they themselves have been saying for years, we need more resources. We're not the best prepared for this. They're a government agency, so they're going to tote the tune as much as they can. We're capable of being an independent regulator. We're capable of doing our job. And they do a great job of interrogating safety cases, as we said. But the process is, their structures, they just had to go through a whole education program to get ready for advanced reactors and everything. And that education program is ongoing. So yes, there are challenges at the NRC. The NRC in many cases recognizes some of those challenges, but does not recognize the other challenges. And in some ways is shooting themselves in their own foot.
Well, I want to come back to that, but I want to know, you introduced yourself, and I just want to make sure that I understand a little bit better who you are, if you don't mind. So I saw you got your undergraduate degree and your a graduate degree, master's in nuclear engineering from University of Florida. And I see your Florida pillows on your couch there behind you. Go Gators. You're required to do that.
Yep.
Why nuclear? Why did you get into nuclear? And tell me about are you from Florida? You a native Florida guy?
Yeah, no, I was born and raised in South Florida. I actually went to that Parkland High School where they had the unfortunate shooting a few years ago and everything. But that high school that I went to was, when I was there, the #1 public school in Florida, and it was a STEM powerhouse. We had, lots of schools, I knew of growing up. Other high schools I would visit would have all the banners of their football and soccer and basketball teams in the gym. Well, we had banners for our math team, and this team, won, state national championships and all that stuff and everything. So a very sort of STEM oriented, high school education. My father is an immigrant. He's from India. He's a doctor by training and everything, but he always was more interested in science and math. And his father, pushed him into medical because that's what he, his background was. And so science and math was always really big in my house growing up. I knew I always wanted to do something science and math related, and engineering became more and more that thing when I was in high school and moving into college and everything. But I had no idea. And I went to University of Florida because, we couldn't afford a lot of great colleges around there. I could have gone.
And if I can interrupt, so at Parkland, was there, the way you're talking about it, I like how animated you are when you talk about it. Was there a teacher at Parkland who said, "Hey, Brett," took you aside and said, "Hey, you need to do this"? Or was this, you said your family was already oriented that way, but was there someone who said, "Go nuclear," or someone that took you aside and said, "Hey, man, you got potential here, go this way"?
No, it was really, I think probably even before I came to high school and my first, math classes and everything, and my teachers and physics classes were like, "Oh, that kid looks like he's going to be an engineer already." I was the the kid that my parents used to scream at because I would take apart the television in the house and everything to see how it worked, or I would be wandering around on trash day and seeing what electronics people would be throwing out so I could take them home in my radio flyer wagon and take them apart in the garage and everything.
Uh-huh.
The cockroach infestations. I'll spare you the stories. My mother, was crazy, but nuclear was not really anything that I had been around or been exposed to. If you did well enough on your SATs in growing up, when I grew up in South Florida, you got a free ride to a public Florida school, and the University of Florida at that time was a spectacular public engineering institute and had two top 10 engineer in the country engineering programs. One was materials and one was nuclear. And my older brother, who was 2 years older, was already at the university, had already started materials, and you needed 2 semesters of chemistry for nuclear and 7 semesters of chemistry for materials. And I hated chemistry. And the nuclear building was 3 steps closer to the football stadium than the materials. So those were literally, I was looking in preview and flipping through the book, and that's how I decided. And my mother was like so angry. She's like, "You can't decide your major this way. How can you do this?" And it was one of the best decisions I ever made.
So, so there wasn't, well, so you're an accidental, some ways, accidental nuclear engineer. And so, but now when you think about back, and I'm just curious because I'm fascinated. I've been pro-nuclear for a long time. If we're serious about reducing emissions, there's no other way forward at scale than nuclear. If we're serious about, preserving the natural environment, reducing material intensity, there's no other way forward than nuclear. It is so obvious. Even Ray Charles could see it. But how do you see the broadly when you think about nuclear now? Given your experience, you've been in the business, in the industry for a long time now. You've been in power plants and seen it from the industry side, and you're talking about policy regulation. How do you see the big picture? Why, if I said to you, "Well, why nuclear? Why now?" How would you answer that?
Well, I think, one of the broadest big picture amazing factors about nuclear right now that I think I could point to is, it's inclusivity, right? And the sort of inclusivity that it's getting right now. Now, for decades, for years, advocates have been asking for an even playing field, not even asking for, hey, we want the same leg up that others got when they were trying to deploy at the bottom of the learning curve and trying to, really, really get that repetitive economic advantage and everything. Nuclear industry in many ways was not saying that. They were saying just stop bootstrapping us and let's all get to the same level at playing fields. And in a lot of ways, the Inflation Reduction Act, the Infrastructure and Jobs Act, I think I forgot a letter there. It's the IIJA. That's investment was the other I. Jobs Act. These bills that came together along with a bunch of other nuclear legislation that has happened, nuclear specific legislation that has happened in several years, have really sort of opened the floodgates to pave the way to say, hey, this is a middle ground issue. This is a bipartisan issue. This is an issue that should be included in the broader discussion on clean energy, on, our energy goals, and it shouldn't be treated as a pariah because, as you said, we, any analysis, any modeling, anything we look at says we need it. Now, are we?
But let me ask you about that because look, I can tell you're passionate. I interrupt my guests a lot, and I know you can keep going. But when you talk about inclusivity, I mean, where you frame that was in the context of U.S. politics, right? Yep. And that there has been more democratic support for nuclear, finally, thankfully, right? But I was thinking, as you said the word inclusivity, I was thinking you might take a more global view, because this is one of the things that in Washington at the IAEA meeting, we interviewed the director general of the IAEA, Rafael Grossi, and he talked about this, that there's been a change now that a view that nuclear should be for everyone, not just the wealthy countries. And so
you beat me to it. I mean, immediately following the IRA passage in this country, Canada started considering similar tax incentives and support for their future nuclear technologies and everything there. Right prior to the IRA, the European Union and European states spent longer than 12 months arguing over its clean green bond investment framework called the EU Green Taxonomy. And the largest sticking points were the inclusion of natural gas and nuclear into that framework, which resulted positively for both of those things, for both of these technologies.
Right. So that's the U.S., that's Europe, but then I would also think that your family comes from India. That the Indians are pushing very fast on nuclear. Pakistan, Bangladesh. All the. It just seems that they're. Well, I'll ask it this way: is it different this time? Is it different? Is the nuclear renaissance, the nuclear comeback, is it different now? And if so, why?
I want it to be different, and it feels different. But to me, it's any of these renaissance, any of these opportunities. I've never been about the technology or about sort of, the larger social zeitgeist or even in a lot of ways about the regulatory environment. It's been about the business models and the deployment models in a lot of cases, and everything. Now, looking at some of these recent deployments of nuclear technologies, and, don't get me wrong, I love Vogtle. I live in North Carolina. I want to drive down to Georgia in a couple of months when that thing's online and climb the towers and everything like that. I'm very confident. I used to work at Westinghouse. I'm very confident that plant is going to work stellarly, up to, its sort of, operational targets and performance targets, if not exceeding them and everything. But we cannot have a repeat of that. And the French EPR process, we cannot have a repeat of that.
And the repeat is that it took them 15 years or
but even looking at Vogtle and looking at its sisters, BC Summer, which, God rest its soul, unfortunately, there's a lot more that went into that than just sort of the regulatory, or because, there were lawsuits, there were poor business practices, there was, design changes and, while you were doing your regulatory engagement and everything. So we've learned a lot from these projects. We've learned a lot in many ways. We've seen everything you should not do. Don't do all of this. If you do, and it was also the preponderance of the things that they shouldn't do. That is the issue, right? Of this Vogtle and the VC Summer project might have been a lot more successful signs of the times of nuclear had they not been burdened with, 57 landmines, had it only been 10 or 6 of these challenges that they had to unfortunately step through. But again, that's what you face when you're doing a languished industry and languished challenge. But we look at
and I think that's it, that languish, that's a good word, languished industry, and that they're coming back with first of a kind, right? And that you're going to have problems with first of a kind. And I talked with some of the consultants on Vogtle who said, they had these designs there, these plans, and the rebar was so close together they couldn't get the concrete into the form. And I thought, well, how could that possibly be, right? So there were a lot of mistakes, but so just handicap. Then let's leave the U.S. aside and the NRC aside for a few minutes. You look around the world, right? And where do you see nuclear succeeding now? I mean, Abu Dhabi, you've got the Al Baraka plants are coming online. The Koreans that built those plants, the Chinese are going full speed ahead. We've had the recent announcement from Samsung about nuclear power ships, which to me is incredibly interesting. And I wrote about that in my Substack just recently. Look around the world and leave the U.S. out of this. Where do you see nuclear gaining the most traction?
Sure. I think you named a lot of them, China, of course, number one. I think they just announced that they're going to do 150 plants over the next 10 or 20 years or something like that. And, Eastern Europe is extremely exciting. We've seen, the Polish announcements, its tender for, new plants, this announcement of splitting the new plant deal between Westinghouse and South Korean vendors. We've seen a bunch of announcements from a nation under wartime circumstances, Ukraine talking about its expansion of nuclear and its wanting to build more nuclear power plants and relying on potentially Western vendors for that. But then also, if you look at a lot of these other projects that are happening or being discussed around the world, they're unfortunately being vended or supported through procurement by Russia or China, some of these actors that we don't necessarily want to be the largest exporters or developers of global nuclear technology. So I'm really, really excited by, hey, an opportunity for, say, Westinghouse or the South Koreans to build, 6, 10 of their reactors in Eastern Europe, a few in more perhaps in Southeast Asian nations that are considering it, like Vietnam and the Philippines and other nations like that, and then use that learning expertise to really be a player in this larger global field and compete with a nation like Russia that can offer things that a vendor like Westinghouse or South Korea cannot, like fuel take back, which is a huge deal when you're trying to sell a multi-generational deal on energy technology to a developing nation that is desperate for energy.
Well, let me ask you then about Rosatom, because they are the leading player, I would argue, in terms of commercialization of nuclear, right? They have the deal in Iran with Bushehr. I believe it's in Turkey. They're developing reactors there. And it's a one-stop shop, right? That they are government agents, government-sponsored entity. They are owned by the government. They can provide the financing. They can provide all the personnel, the technology, the fuel take back. These are all fairly obvious, I think. But is it going to require that, like, or South Korea or in China, CNPC? Is it going to require that, or does the success of nuclear in the global marketplace require a company to have the backing of a government? Is it going to be government championed companies that are going to win?
As a dirty American capitalist pig, I want to say, right? I don't
think you have to couch it quite that roughly, but you can just say as an American dude or American.
I'm kidding around. That's the way, this thinking is kind of demonized these days. But, in my opinion, no, it should not require state intervention or state involvement in these processes.
Okay, but should not. Okay, should not.
But it does require, it should not, but it does require state support. Okay.
Now, and sustained. And that's the key, right? This is then the problem with the United States is, right. What is a friend of mine a long time ago, Nick Reese, I think that was his name. He said, problem with the U.S., the Republicans are pro-nuclear and anti-government. The Democrats are anti-nuclear and pro-government. We need politicians who are pro-nuclear and pro-government. And this has been still, it seems to me, the key sticking point, right? But anyway, I interrupted, but
you're good.
Should be is the key question here. Right?
I'll just say, I think at least in my 5 years that I spent a lot of time in DC, the arguments that we would have between Democrats and Republicans and everything would be less on the nuclear issue and more on the broader issue. So, yeah, I think that part of it is changing because I think a lot more Democrats are becoming pro-nuclear and this is becoming a bipartisan issue and everything. But, getting back to the larger concept of, state support, how can, sort of these sort of totalitarian or, these fully driven sort of state organizations really compete on the broader scale. I think, again, it's a little bit of support and then a leadership from that nation. Now, in a lot of ways, it's very hard for a Westinghouse or another U.S. vendor to say, we want to export you our technology and don't worry, our designs plan for, 80 years of spent fuel storage on site and everything. And we talked about fuel take back, many places are storing fuel. Fuel storage is extremely safe. It's a great, it's a well done. We have lots of expertise in it. But new nations or nations developing new nuclear or new technology resources, in many ways, either don't want to get into the storage game or don't want to expand their storage needs, and rightfully so. So they look at a nation like the US, which unfortunately is still trying to figure out what the hell we're doing with these laws around nuclear waste management, and Yucca Mountain, which is never going to happen now, but is the law of the land and everything. And that's very difficult for a vendor to answer questions from a state, utility
because there's not that long history of government backing. There's an uncertainty about when the regimes will change and then whether that is going to change the regulations. We've already seen this with the NRC rescinding the license extensions for Peach Bottom and Turkey Point. I think if I've got those right.
Well, yeah, it was the petition, unfortunately, that asked them to redo a generic environmental evaluation, which thankfully has just been resolved to the satisfaction of the utilities, and those plants will get their subsequent license.
Oh, okay, renewed. That's interesting.
Yeah, it just happened recently.
But let me follow up then on that, because we talked earlier about the NRC and about the need there, and I know we're hopping around a little bit, but we're all around this very similar theme about regulation, state support. Ray Rothrock was on the podcast a few weeks ago, and I brought this up on several other podcasts, but that he made the point that the NRC is not going to be able to be reformed unless you change the organizational structure. And his point is there's no CEO. And if there's no CEO, there's nobody at the top that can crack heads, kick butts, however you want to put it, to get a change, to change the culture. And I'd never heard anyone analyze the agency this way. He said, you've got the commissioners and then you have the bureaucracy underneath them. But that, anyway, the point that he was saying was that Congress is going to have to act. So that's the question I'm getting to here. Is there the political will in Congress that it has to be bipartisan to pass a bill in this congressional session, which we have a divided Congress, to force through a bill that is going to result in significant reform at the NRC that will make it move faster, that will change the organizational structure, that will allow this pipeline. You said 10 different applications coming down the pipe. Is there something that's going to make this happen in this congressional session? Yes or no?
Yes or no is a tough question anytime in Congress, right? So no, I'll say maybe. I'll say maybe. Can I say maybe? Can I say maybe? And I'll explain
go ahead.
I'll explain my maybe. When I started doing policy work at Clean Air Task Force and really learning about this, 5 or 6 years ago, we were negotiating and, having discussions with bipartisan groups in Congress on NEMA and NECA, the Nuclear Energy Innovation and Modernization Act and the Nuclear Energy Innovation and Capabilities Act, which drove a lot of these new regulatory sort of reforms and changes that we're now sort of living in and experiencing right now. But we always knew back then they were just the start of the discussion. Okay. And even when I I think it was 2021. Yeah, I think it was 2021 when my old boss at Clean Air Task Force was testifying for some nuclear bills, or maybe it was early 2022. And we were prepping and having a bunch of discussions with the staff and everything. All of this came up because following from NEMA and NECA, there were changes made to the NRC fee structures and what the NRC can recover as fees in terms of advanced reactor engagement and everything. If you can imagine, we've reduced some of the burden on the developers already, and it's still this much of burdensome and everything. And a lot of what came back from the NRC following those changes was, hey, those changes didn't work. We can't do this. We need more money. This isn't working. Here are our suggestions. Either roll it all the way back or just give us more money. And those discussions were on I'm not talking about like large line items for doing like large amounts of work at the NRC. These were arguments over percentages around the administrative budget at the NRC. So their overall top line fixed cost administrations and everything. And even in that case, in negotiations in Congress and having discussions where I, myself, many of my colleagues thought, well, the direct solution to this is give the NRC some more flexibility in their budget. and give them a little bit more money. So either you got to move one of these levers. You can either lock it or give them more money, so. But it just became a bit of a log jam because appropriations are a tough discussion right now on anything, right? So what we really need, and there's been many bills, there's been numerous, and the Nuclear Innovation Alliance was working with some representatives. I believe it was, I don't want to, Representative Donalds, I don't want to call out somebody wrongly, but or miscalling out the right person. On fee reform at the NRC, we're probably going to see, I'll just be frank, we're probably going to see some oversight in terms of NEMA and NECA related activities, whether that's direct and real committee oversight or that's, informal backroom oversight. But I definitely think we're going to see some oversight from Congress because the rulemaking for, to be the new rule for licensing advanced reactors, which was NEMA and NECA mandated, according to those future applicants, is not going very well. And according to most anybody, is not going very well.
And that rule was what, 9,000 pages or something? I mean,
it's longer. It's longer than the previous rules. It's now, but that is a function. I think I said before that the road to hell. I apologize. I think I've cursed a couple of times on your podcast.
It's okay. No censors involved here. Go ahead.
The road to hell is paved with best intentions. I believe that. And the NRC was mandated to develop this new risk-informed, performance-based rule by Congress by 2027. But to be really ambitious and to give themselves some space between their congressional mandate and when they would be issuing the rule, when those laws were passed in 2019 and 2020 and all became, signed into law and everything, and the NRC had to start planning, they said, no, we're going to make this rule by 2024 instead of 2027. So they pushed it back 3 years. They said they had 3 years, 3.5, 4 years to get this all done. And in many ways, when the NRC said that, the staff came back to them and said, well, if you tell us to do it this way in this kind of time frame with these resources, all we're going to be able to do is take from what we've done previously and try to combine it together and put it all together. We're not really going to be able to innovate.
Right.
And so the NRC said it's more important for us to meet the congressional mandate than it is to kind of risk it in terms of doing this real work, which we might need more funding for and be more challenged about and everything. So it's all interconnected and tied together, and they were hamstrung from themselves, but then cut their own Achilles tendon in their own foot because they were hamstrung to begin with.
Well, so if I read this back to you, Brett, what I hear, and as we've talked about these different parts of this, is that we're facing a really intractable bureaucracy that is for all of this, the things that need to be addressed, that this is the key roadblock. And we talked about that before. So if you don't mind, let's set this aside for just a second and talk about, well, what about Europe then? So there's the possibility the British are talking about permitting Rolls-Royce. Rolls-Royce has an SMR that looks interesting. Rolls-Royce is an old line industrial company. They know how to build heat engines, very sophisticated outfit. They're talking about putting up an SMR that could be deployed by 2027, if I'm not mistaken. Is the U.S. going to lose the race to deploy the first SMR?
Well, so number one, the SMR in the UK that Rolls-Royce is developing would not meet the US federal definition of an SMR because it's too large. It's essentially, I think
was it 400 megawatts? Was that right?
440 megawatts, I believe.
Yeah, right. Yeah.
And the requirement in the United States or the definition in the United States is 300 or less. The Rolls-Royce product looks very much like a 3-loop light water reactor that we've deployed in this country or in other countries in years before. So the innovation sort of learning curve climb on that Rolls-Royce technology is a lot less. So will that probably be easier for them to deploy also with I hate to say it, a somewhat century long relationship with a government that has always been super supportive of your activities and everything, I think Rolls-Royce is in a very good situation in the UK, you know?
And further, I mean, this is the other part that it seems to me that other people on the podcast have said, well, the nuclear has to succeed overseas before it succeeds here. And as part of that, in fact, Mark Nelson made this point. He said, the US is not under the kind of same pressure that European countries are. So Britain could then, in theory, you bring that point about Rolls-Royce having strong government backing. They, you know, their ships, their submarines, their a lot of their aircraft engines, et cetera, closely tied with government contracts, that the Brits could have their own regulator. They could have their own fuel supply systems. They could do all of this. They won't face the same kind of friction with the NRC. So if you look at the Europe as just the European countries, would Britain then have potential to make this happen sooner than other European countries because of the things we've just mentioned?
Well, you know, we talked about regulatory, and we also briefly touched on it, but you know, I don't think the regulatory piece is certainly a big part of it, but there's larger pieces, or there's as large pieces as the regulatory piece. And for Europe, that's going to be waste. And the EU taxonomy calls for the deployments of any projects that are going to get financed through that project to have a clear line of sight to a waste management program or solution for those nations deploying that technology. I think it's a 2050 horizon, so it's an incredibly, you know, it's a long ways out, but still all of these nations and the loan sort of officers and the, you know, the loan offices around these programs are going to sit there and going to be deeply interrogating these projects and say, Rolls-Royce, this is great, but you can't just store the fuel in the parking lot like you do at like this design calls for and everything.
Well, but fair enough. But doesn't Brexit take the EU out of the equation for Britain then? I mean, you know, they're not part of the EU now. So in theory, they could say, well, you know, that was old stuff. That doesn't apply to us anymore. And Britain, you know, depending on who you believe, they are of all the European countries under the biggest pressure because their North Sea gas production is plummeting. They can't rely on the French for their electricity. They've got to do something, and they've got to do it pretty quickly.
Yeah, so, no, I think those plans in the UK for Rolls-Royce to build a bunch of reactors are, number one, good plans. You know, I like those plans. And number two, will, you know, potentially have a very good chance of coming to fruition. You know, more so I was talking about the export opportunities in terms of that. You know,
I see. Yeah, right. So Rolls could do it in Britain, but then they will, if they're going to do it in Europe or elsewhere, they're going to have to deal with the issues you just brought up about the EU and the waste. I see. Okay, yeah.
And if they're going to do it, and if they're going to export to Africa or to other nations, you know, Southeast Asia, you know, a lot of those nations have very, very different sort of energy demand and energy growth needs than Europe or the Western world. And so in SMR, quote unquote, a Rolls-Royce SMR that looks very much like a small 1960s, 1970s reactor, but and the nation that you're providing it from doesn't bring all the rest of the things that, say, a nation like Russia or China offers, then it becomes a difficult challenge for Rolls-Royce to compete for that energy demand and everything else that comes with it. Hey, I'm Rosatom. I'll come in. I'll build 3 VVERs for 4,000 megawatts. We'll take the fuel back. We'll finance the project for 100 years. We'll even send you workers if you really wanted to.
Right. Yeah.
That, you know, so a lot of that is the bigger challenges here. Now, let's talk about like SMRs and microreactors and the ways that those can really kind of help change this paradigm, right? And everything. You know, I just got back. I just went in September to my old employer, Westinghouse, and saw their microreactor model on their electrically heated model on the lab desk and everything. And because this is a small micro thing, it would fit like, you know, I mean, I can't fit it in the camera view right here, but it would fit on your coffee table or on your dining room table.
How many kilowatts of output?
It's I believe they say it's 8 kilowatts, or excuse me, 5 kilowatts of electricity, 8 kilowatts of heat can be both at the same time or scale it in different ways and everything. They want to send them, install them for 9 to 11 years, and then the whole thing is shipped back to Westinghouse, back to their factory. They ship you a new one, and you just plug it back into the piping or whatever you have on site that you need for. So it becomes the product as a service, and they don't have to do waste storage. And it also offers Westinghouse now, the opportunity to think about what do we need to really be thinking about if we want to look at the back end of the fuel cycle, because we're now going to be talking about storing this stuff. Should we be recycling it? Should we be doing different stuff with it and everything? And
I'm sorry to interrupt, but this is fascinating. I haven't heard anything about this. As you're saying this, 5 kilowatts, almost like a nuclear battery.
It's called eVinci. It's called the eVinci.
But as you're saying, so I'm thinking, well, as a nuclear battery or a nuclear cartridge, almost like you'd get a cartridge. Oh, well, I got this little package and it's in the mail, but 5,000 watts. I mean, I could run that at my house, right? I mean, this would be great. I mean, my demand is maybe somewhat lower.
Might be a little rich. Might be a little rich for your blood, but maybe if you live on a cul-de-sac, maybe you and the whole thing. Right. There are models like that. They're probably not going to happen into the future and everything. But thinking about some of the people that I work with now at Veriten, thinking about like some of these people in the traditional energy communities, they have large existing electrical and broad energy needs, heat, other forms of energy. There's I've seen estimates that say the electricity demand just in the Permian Basin is going to double or triple in the next 36 months, just from the new drills. Right. Not just when you start talking about electrification or electrifying compressors or reducing the amount of diesel in these operations and everything. So when these operators are looking at the challenges that they're facing and they say, hey, I need electricity, I need heat, I need both, I need all of that, and you look at these micro reactors and these small modular reactors that are offering higher temperatures or offering, energy and heat as a service more than what we've seen previously and everything, it starts to open a whole new world and open up a lot of different opportunities. So, I hate to say it, perhaps the biggest movers, because I know this is, your bailiwick, near and dear to your heart. This is where I started my career. Power in the United States in the next, 10, 15 years might not be the biggest opportunity for nuclear in the US. We'll definitely see some power deployments, but, all of this heat, all of these, the NASA just announced nuclear thermal propulsion rocket cooperation with the Department of, the DARPA, the Defense Research Projects Agencies, on Draco for a nuclear rocket to Mars. We have, developers that are talking about pairing with chemical developers like X Energy and Dow to provide heat in chemical operations in the US and everything. So I think it could be a lot of different things. The ships, the marine applications that you talked about, and it might not be the regulatory challenges that people are really trying to jump over. It really is, hey, do these things different and do it for these new, more novel sort of applications that have probably no other competition and a large sort of backlog of opportunities. And you could really see a logjam break up.
That's interesting, and I'm glad you brought that up. And a quick station break. My guest is Brett Rampal. He is the Director of Nuclear and Power Strategy at Veriten. You can learn more about him and Veriten at veriten.com, Veriten. Well, I'm glad you mentioned the X Energy Dow announcement, because that, as I look at the landscape, and I've talked about this before, it's one of the most intriguing of the different announcements that have been made around nuclear. NuScale, of course, has made an announcement that they're in talks with the Jordanians, the Poles, a bunch of other customers internationally. You've got the TerraPower with Natrium talking about their project at Kimmerer, Wyoming. But Dow and X Energy to me was fascinating because here's Dow, a very old line industrial company, a very conservative one, saying, "Oh, we see the value in X Energy, which is a different breed of cat than what we've been talking about. It's a gas cooled reactor, but Dow, the way I read it and what I've heard the people at Dow say is, we're interested in this because of the opportunity for thermal." The process heat, and that they've said they are targeting potentially deploying one of X Energy's reactors at a Gulf Coast petrochem plant that they have, and they have a lot of production capacity in the Gulf Coast. But that to me is interesting. It goes to your point about thermal, in that that is another opportunity that is separate and apart from connecting to the grid, and that maybe X Energy does this deal and they never sell any power into ERCOT or into the SPP or wherever. Instead, they either use all the power themselves or they just concentrate on the thermal output. But I read it as, hey, we don't want to burn natural gas molecules to produce power. We want to save those molecules and turn them into plastics or whatever else. So I'm glad. So what those other opportunities? So would be refining petrochemicals. Wouldn't be mining though. There in mining there isn't that much of a need for thermal. It's more of an electric load there.
Well, I mean, there is a need for remote power in mining,
yeah,
right?
yeah,
And everything.
right.
So it's cogeneration and everything. There could be heat-based operations at some mining operations, whether it's hot water or heat heat rock fracturing. I believe they use some heat processes in some rock fracturing.
Oh, that's right. Yeah.
So there are opportunities. People don't really realize how much fossil fuels and heat goes into making everything we live on. You mentioned plastics and petrochemicals. One of the big markets around the world that is kind of low temperature, low grade heat that people don't really talk about, but is fundamental to life. Textiles. Textiles is 160 or something like that gigawatt global heat market. And I believe most of the heat in those systems could be satisfied by heat coming that could come from existing light water reactors and small, that sort of temperature, not just the higher temperatures coming from the higher temperature advanced reactors. Our friends at the Nuclear Energy Institute just recently had the Adidas global brand and fashion. I'm going to get their title wrong, but I believe it's their global brand and fashion director, who said that at Fashion Week this year, they want to have a demonstration about how nuclear could play a huge role in decarbonizing and revolutionizing and making the full fashion industry clean. And so that's a fundamentally crazy way to think about.
And so their heat would be in dyeing of the fabrics, or I'm just thinking
in making fabrics, in making lots of times all of these factories that are cutting fabrics and sewing fabrics and dyeing and doing everything are in poorer nations, and they're not run on electricity. They're run on steam or heat-based systems in a factory and everything. And so, what does that look like? It might be giant steam fabric presses, or it might be giant steam powered sewing machines. I don't really know. I haven't really dug into it that deeply but I do know that there are all of these markets out there where we use a lot of heat, and the majority of that heat comes from
hydrocarbons.
Hydrocarbons. And it's unabated hydrocarbons right now and everything. And so that's a great opportunity for nuclear heat to play a role. And the electricity challenge, people think about electricity usually first, right? And everything.
Sure.
Electricity is a third of the challenge. Transportation is a third of the challenge. And industry and manufacturing is a third of the challenge. And if we go back 20 years and we say not electricity, because electricity has seen those trends and a lot of renewable penetration on the global scale, at the last 20 years. But if we go back 20 years and we say just global primary energy usage, okay, 20 years ago, 80% unabated fossil fuel use based and everything. Today, global primary energy usage is 80% unabated fossil fuels. We've just changed the gas and the coal percentages, and we've shut down some nuclear and allowed that to be replaced with a bunch of renewables on the grand scale of things.
Right.
So
Well,
there's that huge chunk.
that's an interesting point because the renewables are not going to be able to fill that process heat niche. They just can't do it, right? Because they're going to have to go through it. Well, you can create the electricity and then turn that into process heat, but it's
Or
less,
make the hydrogen and then burn that and
which is
everything.
less efficient, and
Yep.
you've got all the conversion problems. So let's talk about fuel a little bit because we've been talking for nearly an hour, and I want to talk about the fuel issue. Um, TerraPower announced they were delaying their project in the Natrium project in Wyoming by 2 years because of lack of HALEU, high assay low enriched uranium. Talk about the fuel cycle. To what extent is the U.S. going to be able to ramp up its own fuel production capacity, both from uranium mining and the enrichment? This is an area I know very little
Sure.
about, and I know that Centrus Energy they're a publicly traded company. The stock ticker's LEU. Bring me up to date on that. It's an area I know very little about, honestly. And are we going to see a resurgence of uranium production in the U.S.? Or are we going to depend on the Canadians? And then how are we going to get the enriched fuel for reactors in the U.S. and around the world that it doesn't come from Russia?
Sure, sure. So for your listeners and viewers and everything, uranium fuel cycle, life cycle and chain and everything, we mine the rocks out of the ground and then we are essentially converting it into a gas, and then we are using that gas to enrich it to increase the amount of the isotope that we like. Heavier stuff goes up, lighter stuff goes down, or heavier stuff spins around, and you separate things out and everything. That's where you might have heard of centrifuges in enrichment before. And then we need to after we enrich it, we need to deconvert it. So we need to get it out of the gas, and then we can then manufacture it into fuel, which we then load into a reactor at that
Good.
point. So
Thanks.
it's a whole life cycle. And the largest actual challenge on that life cycle right now for us looking into the future is actually, unfortunately, conversion on that. Now, the conversion market and the enrichment market right now on a global basis is dominated by Russia, unfortunately. They between 40 and 50% of enrichment and conversion global capacity. The numbers are different between the two, but they're both between 40 and 50%. And last year, or I think it was 2021, which is the year we have the most recent numbers for, 20% of the uranium in operating existing reactors came from Russian mines or Russian uranium services, or conversion services, enrichment opportunities as well. So it's a challenge. Now, if you look back to when I was selling or making fuel for my customers, when I was at Westinghouse and everything, we would have pointed to Russian fuel and uranium relations as a great shining beacon of, globalization and trade opportunities. Up until 2013, we were down blending Russian weapons into U.S. nuclear reactors. And so we were increasing our non-proliferation goals around the world, as well as getting cheap, very, very cheap uranium in U.S. reactors. And as soon as they could, the Russians got out of that program in 2013, and that ended, but that still left reliance on Russian supplies. And their market was able to jump in and say, hey, we can provide this, not as cheap as you were getting it, do that treaty and that law, but we'll still give it to you cheaper than you could manufacture it in your country. And you could not manufacture it, then you can mine it, and that you can enrich it and convert it to your own country. And so that's how they started to build this wedge in the market. And that's how we ended up seeing US players decline. So we no longer have a strong mining all this. But we
so just one quick point. So that was what was it, megatons to megawatts? This was the nuclear weaponry and the fuel for nuclear weapons that the Russians had. That a lot of that fuel that was, or a lot of that material that was in those nuclear weapons, was then taken and put into civilian use. So I just wanted to make that quick point.
For 2 decades,
that set the stage then for, once that ended, for then the continued reliance on Russia, but except instead of the old weaponry that was providing that fuel, it then became Russian industry that became the big provider.
Correct. And
Okay.
for, I think it's about 2 decades, maybe longer, ending in
Right.
2013,
Yeah.
10% of Americans got their electricity from downblended Russian weapons.
Right. Yeah.
So, so that's, again, that's a great success of global, relations and trade. But now we're in a whole different world, right?
And that set the stage for the dependency on the Russian supply chain then.
And you can even look at, we get uranium from a lot of sources that are non-Russian. Some of the three, like sometimes some of our largest suppliers of uranium for the US are Australia and Canada, which are nations that we should have no problem with having long-term, uranium relations with and everything. But then our other nations like Kazakhstan and Uzbekistan, and you look at nations like that have great uranium resources but are landlocked, and all of their resources used to travel through St. Petersburg, and now the discussions are Chinese swaps, or how can you get it by, without doing Russian financing. So it's a very, very difficult and challenging opportunity, or challenging space right now for both the existing fleet and for these future advanced reactors. If we had to get off of Russian uranium services and supplies right now, the entire world, meaning India and Japan and everybody else, the US, others would experience challenges in keeping our our existing fleet online. Probably not this year, probably not next year, maybe the following year, maybe the year after that, that sort of time frame and everything. So yes, this is a very tight market right now, but maybe if India and Japan kept buying the uranium, we could get out, but there's lots of different opportunities here and lots of different challenges. You mentioned Centrus. We have hundreds of millions of dollars in funding coming from both the IRA and from previous funding sources through the Department of Energy's Nuclear Fuel Availability Program to kind of revitalize this sort of enrichment and conversion capabilities in the United States, as well as sort of build and create new sort of capacity that we never had. The advanced reactors need fuel that is slightly more enriched than the existing reactors, and we've never provided that commercially in this country. But
now you're talking about HALEU there specifically.
Yes, sir. Yes,
okay,
yes.
Right. And the natrium reactor requires HALEU. X Energy requires HALEU as well.
Yep.
And the molten salt or the molten salt reactors, they're going to require HALEU as well. This is an area
the only molten salt reactor company that I know of right now that is not pursuing HALEU is Terrestrial Energy, and they are pursuing a low enriched uranium molten salt reactor.
And Terrestrial is the Canadian company. Their CEO Simon Irish has been on the podcast, right? But they're based in Ontario, and they have an interesting, but they domiciled in Canada purposely because of.
And they also have a U.S. operation now. They're engaged with the NRC, in some ways.
Right.
It's called Terrestrial Energy USA.
Right, so. And they're pursuing dual licensing in the U.S. and Canada, and trying to bridge that divide. Well, so Brett, we've been talking for about an hour now, and I like to keep the podcast at about an hour, and I'm glad we were able to we've covered a lot of things. So I ask my guests, always ask, they introduce themselves. What are you reading? What's on your bookshelf or the top of your book list, book pile?
Right now I'm reading Bomber Boys, and I'm sorry that I'm going to forget the author because it's a fantastic book. It's actually being turned into a mini series by Tom Hanks and Steven Spielberg for Apple Plus TV, whatever these streaming services. It's supposed to be the next Band of Brothers. It's the story of the brave and courageous men that flew the strategic bombing missions during World War II in the B-29s over Europe. It's a fascinating and sometimes heartbreaking book. So,
by Travis Ayers, is that what I'm?
Maybe. I thought it was
Bomber Boys, the heroes who flew B-17s in World War II. Is that I see several different.
Let me see
titles of Bomber Boys.
I thought his name was Daniel, something with a D. Bomber Boys. I don't get it from I'm sorry. I should have been prepared.
No, that's fine.
Spielberg, Hanks. I'm sorry, it's not called Bomber Boys. That was a different book.
Oh, okay.
It's called Masters of the Air.
Okay. Good.
Masters of the Air.
And the author,
America's Masters of the Air, America's Bombers Boys.
aha. Okay.
Sorry.
And who's the author?
The author of that is oh goodness. Now it's giving me everything about the series. No,
Okay.
I want the
No,
author.
no problem.
I'm sorry.
Uh, Good. Okay. Anything else you want to mention there? And Donald L. Miller, it says here, Masters of
Donald
the Air.
Miller, yes, something with it. There you go. So yeah, no, the only other thing I'd mention is, it's been an absolute pleasure. Thanks so much for having me. And I just
Wait. No. Any other books? Don't go. Any other books you're reading besides Masters of the Air?
Not right now. I have your book on my stack to pick up next and everything.
Attaboy,
I just
there it
saw
is.
you the other day.
Question of Power, Electricity,
Yep.
and the Wealth of Nations. Yeah, everyone needs to read that. You don't have to, actually, you don't have to read it. You just have to buy it. That's my line. Okay, good. So then my last question then, Brett, what gives you hope?
Well, like I said, I think this sort of trend that we've seen, I mean, if I look at last year and if I look at 2022 versus 2017, the first year I started doing policy and research and advocacy work as full-time job versus the last year I was doing that. Now, the new life I've moved into and everything. The changes for, nuclear and for the broader world as a whole on the back of that have just been fantastic. I never would have thought we would have seen that Diablo Canyon debate and see Diablo Canyon's life extended, when they first had those discussions. This inclusivity in the IRA is fantastic. I think these trends set a playing ground that gives me a lot of hope that maybe we can make these deployments happen and maybe we can meet these commitments, because we're not going to do it any other way without these technologies,
without nuclear.
And it's important that this head waves continue, these changes continue.
Well, we'll leave it there then. That's a good summary. My guest has been Brett Rampal. He's the Director of Nuclear and Power Strategies at Veriten. Veriten.com is where you can find out more about him. Brett, thanks a million for coming on the Power Hungry podcast. It's been I learned a lot here, and I'm always happy guests who can, explain things that it's one of the reasons why I do the podcast. So it was great fun to chat with you.
My pleasure. Anytime.
And thanks to all you in podcast land for tuning in to this episode of the Power Hungry podcast. Tune in again for the next one. It might be as good as this one. Until then, see ya.